Welcome, geometry students, to your ultimate exam prep boot camp. If you've been staring at a PDF full of points, lines, and equations, just kind of wondering how to make sense of it all before test day, well, you are in the exact right place. Today, we're going to decode the Cartesian coordinate system together so you walk away absolutely confident. We're turning this explainer into your own personal study session, where we literally teach you everything with examples and solve those equations step by step. Let's just dive right in.
So here's our syllabus for today. 1. Navigating the coordinate city. 2. Distance and section formulas. 3. Triangle areas and collinearity. 4. Mastering slopes. And 5. Translating the origin. Let's do this. All right, section 1. Navigating the coordinate city. The core concept here is, honestly, brilliantly simple. The Cartesian system is just a way to fix any point's position using two intersecting perpendicular lines. Right where they cross, that's the origin, 0, 0. From there, we're basically just measuring distances along these two lines to pinpoint exact locations. It creates this ultimate infinite city grid. Think of plotting an XY coordinate exactly like giving a taxi driver directions. The x-axis, which your textbook calls the abscissa, tells you how many avenues to drive east or west, and the y-axis, the ordinate, tells you how many streets to go north or south. So, say you see a coordinate like 3, 2. It's just telling the driver, hey, go 3 avenues east and 2 streets north. Just keep that simple analogy in your back pocket whenever you feel a bit lost on the graph. Moving on to section 2, distance and section formulas. Okay, so to find the length of the shortest path between any 2 points on our grid, we use the distance formula. And actually, this perfectly illustrates a concept you probably already know. This big, intimidating formula, it's literally just the Pythagorean theorem in disguise. You're just finding the horizontal distance, squaring it, adding it to the vertical distance squared, and then taking the square root of the whole shebang. Let's make this super practical. Here's a classic exam question straight from the source material. Example 13.1. Can we find the exact distance between point A at 14, 3 and point B at 10, 6? Just imagine these are 2 buildings on your city grid, and we need to know the straight line distance between them. Let's break this down step by step, just like you would on your test. First, identify your coordinates. x1 is 14, y1 is 3, x2 is 10, and y2 is 6. Now we plug these specific numbers directly into our formula. We get 10 minus 14, which is -4, square that to get 16. Then we take 6 minus 3, which is 3, square that to get 9. 16 plus 9 gives us 25, and finally we just take the square root of 25. And just like that, all that complex math simplifies down to a perfect 5 units of distance. See? No sweat. The absolute crucial point here is to not let the long formula scare you. Just systematically drop your numbers in, square them, add them, and root them. But what if you don't want the total distance? What if you need to find a specific meeting point exactly along that path? Like, say you want to meet a friend at a spot that divides the path into a specific internal ratio, like 2 to 3. For the exam, you're definitely going to want to lock this section formula into your memory. You cross-multiply the ratio values, m1 and m2, with your x and y coordinates. Yeah, I know, it looks super messy, but just like the distance formula, it's really just plugging in numbers to find that perfect middle coordinate. All right, section 3, triangle areas and collinearity. So normally, you'd calculate the area of a triangle by finding the base and the height, right? But what if the triangle is floating diagonally on your graph and those are really hard to measure? Well, instead of relying on a base and height, this determinant formula lets us calculate the area of any triangle strictly using its 3-corner coordinates. And it cycles beautifully. Look at this. x1 pairs with the y's from points 2 and 3, x2 pairs with points 3 and 1, and x3 pairs with points 1 and 2. Now, don't let that long string of variables intimidate you. Let's apply it directly to textbook example 13.8. We've got 3 vertices here. A is at 3, 4, B is at 6, -2, and C is at -4, -5. Let's solve this equation together. First things first, we carefully substitute our values right into the pattern. We get 1/2 of 3 times the quantity -2 plus 5, plus 6 times the quantity -5 minus 4, minus 4 times the quantity 4 plus 2. Phew. Okay, let's crunch that down. It gives us 1/2 of 9 minus 54 minus 24. That leaves us with -69 over 2. But, and this is a fundamental rule of geometry you can't forget,
Physical area must always be positive, so we take the absolute value.
Boom! Lock this final answer into your mind. The exact area of that triangle is exactly 69/2 square units. Honestly, if you can handle those negative signs carefully without tripping up, you are going to ace these questions on the test.
But wait, here's a totally crucial theoretical question for your exam. They love to test your conceptual understanding, not just your calculation skills, right? What does it mean physically if we run this exact formula, plug in 3 points, and the area equals exactly 0? Like, how can a triangle have 0 area? Well, that brings us to the fundamental definition of collinearity. If the area is 0, it means those 3 points just form a flat, straight line. There is absolutely 0 space inside. So if a test question asks you to prove 3 points are collinear, all you gotta do is plug them into that triangle area formula and show that the result is 0. Game over. Next up, Section 4, Mastering Slopes and Angles. You can just think of the slope as a number that quantifies steepness, and there are 2 main ways to find it. If you happen to know the angle the line makes with the horizontal x-axis, we usually call it theta. The slope, which is denoted by the letter m, is just the tangent of theta. But if you only have 2 points on the line, you find the slope by dividing the change in your y-coordinates by the change in your x-coordinates. Good old rise over run.
Now, for your exam, you absolutely must memorize this side-by-side visual rule. If 2 lines are parallel, meaning they never ever touch, they have perfectly equal slopes, m1 equals m2. But if they're perpendicular, meaning they cross at a perfect 90-degree angle, their slopes are negative reciprocals. Mathematically, that just means if you multiply slope 1 by slope 2, the result is exactly -1. I guarantee you, expect to see at least one algebraic puzzle based on this exact rule.
And finally, Section 5, Translating the Origin. So sometimes equations get incredibly messy just because they're drawn super far away from 0, 0. But if we shift the origin to a completely new point, let's call it h, k, we actually transform the coordinates of any point in the plane. To find the new updated coordinates, x prime and y prime, we simply subtract the new origin's coordinates, h and k, from the original x and y. Let's test this out with example 13.26. Suppose our original point is sitting at 1, 2, and we decide, hey, let's shift our origin to -3, 2. Let's use our translation cheat code. For our new x prime, we take our original x, which is 1, and subtract our new origin h, which is -3. 1 minus -3 is 4. Then, for y prime, we take our original y, 2, and subtract our new origin k, which is 2. 2 minus 2 is 0. So relative to our brand new origin, our point is now located at 4, 0. Super easy math, but a really huge conceptual shift. All right, you are now fully armed with the formulas and concepts you need for your geometry exam. We've navigated the grid, found distances, calculated areas, mastered slopes, and even literally picked up and moved the origin itself. But I'm going to leave you with this provocative thought to chew on as you study. We just learned how to shift our mathematical city grid left, right, up, and down. But what entirely new, wild trigonometric formulas would we need if we decided to, say, rotate the city streets diagonally? Think about how those coordinates would change. Keep that curiosity alive, good luck on your exams, and keep learning.